Welcome, and in this lesson, we're going to learn how to archive, compress, unpack, and uncompress files using tar, star, and gzip. And we'll learn a little bit about bzip2 as well. So first, let's talk about one of the most popular archiving utilities called tar. Tar is an archiving utility that does not do compression. You can pass it an option, or also known as a flag, to send it through bzip2 or xz or gzip compression. However, the program itself doesn't handle compression. It relies on a third-party program like gzip. So what tar does is it allows us to create archives. Now, generally, tar was created for tape archiving back when tape archives were more popular, but we've kind of moved past those in the corporate environment these days. So tar is still a popular tool for creating archives and then compressing those archives. So for example, I'm going to go ahead and issue a few commands here to create a new directory. I'm going to do a make dir directory1. I'm going to navigate into directory 1, and I'm going to go ahead and just touch a few files. Touch file 1, file 2, file 3, file 4. Touch is a command that allows us to touch a timestamp. So I can update the modified time, the creation time, the last access time. That's what touch allows us to do. And if a file doesn't exist, the touch command will by default create the file. Now I can pass a flag to the touch command to specify not creating the file if it does not exist. Now that we have those, we have a directory. Inside of our main directory that we were just working in, let's also do a touch. We'll call this hello1, hello2. And we have 2 files in there. Now, if I want to tar an archive, creating an archive means creating a group of files. Now, one thing I know that I can compress each individual file using gzip. So I can say gzip hello2. And we've compressed the hello2 file. Now, I can gunzip that or do a gzip-d for uncompress on the hello2.gz file. And it uncompresses it. But what happens when I try to compress a directory? Well, when I try to compress a directory, I can't do it. Now, I can recursively compress all the files in the directory, but that'll create multiple compressed files. Instead, what I want to do is I want to try to figure out how I can compress directory 1 and all of its contents. Well, to do that, what I need to do is I need to create an archive, which is basically a grouping of all of the files in itself. So first, let's go ahead and create our archive. I'm going to use the tar command to do this. I'm going to pass it the -c option. The -c option stands for create a new tar file and then write the existing names that we're passing to it. V is verbosely. We want to see what's going on. And then next, I'm going to do F. F means use the archive file. Well, that means I need to specify a name of our archive. I'm going to call it myarchive.tar. And then I'm going to specify the files I want inside of my archive. Well, first, I want directory 1 in my archive. Then I want my hello file in my archive. And then I want my hello2 file in my archive. Now, because we passed it V for verbosely, we see that it adds all of these files. It tells us what it's doing. And then when I hit ls here, it's created a myarchive.tar file. Now, first, I want to also take the opportunity to show you that I knew I could enter multiple files here because of the ... So that's how I knew when I typed in my directory 1, hello2, all of those would be added to my archive.tar. Now, my archive.tar, when passing the name, I have to pass the -f flag. The -f flag represents use the specific archive name that we're specifying. So we use this when creating and extracting tar files. Now, let's say I have this new tar file here, which is just a grouping of our information. So when I want to compress a directory, I need to first add a tar file out of it, create my archive. So let's take a look. I'm curious, what files are inside of my tar archive? So I can just do a tar-t and then an F to specify my archive.tar, and it's going to show us what files are actually located inside of my archive.tar. So that's what the T flag does. And then I need the F flag to specify the archive that I want to look at. So now that I have tar completed there, I can actually use gzip to compress my archive.tar. Now, if you notice, I used two different commands to do this. I first created the tar archive, and then I created the .gz file. And if we do an ls-al, we see that it is smaller in size, 220. So let's go ahead and create a new archive, but use a flag which allows us to either filter it through bzip2, which is a compression utility, or filter it through gzip, which is also a compression utility. So let's go ahead and create a new one. So we're going to go ahead and create the archive verbosely. I'm going to pass it through the gzip. So I'm going to pass it the z flag. And then from here, I'm going to specify the archive name. So we'll do my archive 1. And since I'm passing it through the gzip archive, I'm going to go ahead and name it .tar.gz. And then from here, I'm going to specify the directory that we want, the files that we want in there, and then hit enter. Now, if I do an ls-al again, we see that we have our archives available to us. The file names were a little bit different, so the sizes are relatively close, but it represents it also going through our compression utility. Versus if we were to just do a tar, create verbosely, then our file name, we'll call it myarchive2.tar, then our directory file, our hello world file, and our hello2 file. We'll do an ls-al. We see that it's a lot larger in size. So what I was able to do is I was able to first create my archive.tar.gz by first creating the tar, then filtering it through gzip using the gzip command. Then I created my second one by just specifying an additional flag on my tar utility to send it through gzip when tar is working. So I didn't have to use my gzip command. Instead, I just told tar to use z, which is filter it through gzip. Now I can filter it through bzip by specifying j. If you're curious on what other flags are available, always check man tar in order to make sure you know all of that information. Now, what do I want to do when I want to uncompress an archive? Well, first, the question is, do I want to just uncompress the tar archive, or do I want to also extract the contents of tar archive? So let's go ahead and just do a gunzip or a gzip-d, which also means decompress. And we're going to decompress my archive1.tar.gz. So if I were to remove my directory by doing an rm-rf, R here means remove recursively. So remove everything inside of directory 1 and then the directory 1 directory itself. Force means don't prompt me to make sure I want to remove it, just remove it. And then I'm going to remove hello 1 and then I'm going to remove hello 2. You notice I didn't do an F there force, so it prompted me. And I know it's going to prompt me because if I do an alias on RM, by default, Red Hat Enterprise 7 says use the rm-i command when you type rm. Well, what that means is prompt before deleting to make sure that's what the user really wants to do. So now that we've just extracted my tar file, and it would have overwrote our information here. So now that we've extracted it, and I've removed those, because basically I created a backup archive, let's go ahead and extract it using tar now. We've uncompressed it, now we need to extract it using tar. So I'm going to extract. Instead of create, I'm going to extract. So I do the X flag. Let's do it verbosely, and we need to specify a archive name. So I'll do the F flag and specify myarchive1.tar. So here it says what files it extracts as part of our archive. Now let's go ahead and echo some contents. We'll echo test into hello 1. The reason I want to do this is because let's demonstrate what happens when we decompress an archive that has contents that is different but has the same file name. So our hello 1 inside of my archive.tar.gz doesn't have any text in there, but the newest one on our system does. So what do? Well, first, let's go ahead and extract my archive. Well, I don't want to uncompress it or decompress it or unpack it with gzip, then do it with tar. Instead, I just want to do it with all one command. So I want to extract it. After I'm done extracting it, I want to filter it through my gzip utility because that's what we compressed it with. So by doing Z, it's going to filter it through and uncompress it. I'm going to specify verbosely and then a file name, my archive.tar.gz. And then let's extract. And if we do an ls and we cat our hello1, well, what happens is when we extract it using tar, the contents of whatever is in our archive, if it has a file name, is actually going to overwrite the existing information. So if we're exporting or unpacking a backup, but we have newer information, it's actually going to override it. So that's something that we need to think about when using the tar utility. So when extracting, maybe I want to be sure that I'm not going to override existing files, because we know that when we extract it with the flags that we used, it's going to override our files when we're using the tar utility. So before I extract, maybe I want to see if there's a difference between what's in my archive and what that difference is. So in fact, I can do a tar-d. I'm going to do it verbosely. I'm going to specify my file name, my archive.tar.gz. And what this is going to do is it's going to show the difference of our system. So what we're seeing here is modified time differs and size differs. So maybe I want to make sure that my hello1 isn't a recently updated file. But I can look at a comparison of what's in our current working directory and a file and view the differences between the files in there and not in there. So that concludes it for tar. We also learned how to use the gzip utility with tar and optionally the bzip utility if we want to run it through a bzip2 compression with the -j flag. Now gzip is very useful to us, and let's just go ahead and do a few things with gzip. I'm going to go ahead and gzip hello1 and hello2. What that does is it creates two files. So this is why we tar a group of files. We create an archive of a group of files and then pass it together, because gzip is just going to compress a single file for us. So now that we've done that, let's go ahead and just do a gzip -l on hello1.gz. What that's going to do is it's going to provide compression information or compression ratio, which determines how much it was able to actually compress. Now, our file didn't contain any content, so it's kind of a skewed ratio right now. So that provides compression information about an archive. I can unzip by either using gzip-d file name or gunzip. That also decompresses, or also known as unpacks, a compressed archive. So let's go in and look at another utility called star. Now, star by default is not installed on the system. So if you were to have to use this on an exam, what would you have to do? Well, you would probably have to do a yum install star, install it, and now it's installed on the system. Star is an archiving utility, which again is not installed by default, similar to tar. In fact, we're going to call it tar files when we create it because it's just easier for archiving purposes. Now, star is generally used for large data sets of information, making sure we don't overwrite updated files on the file system. It includes a lot of useful utilities, like when we use the find command, we can actually search through and find files in a tar archive and just extract those specific files. Or we can tar specific files by using the find command as a parameter that we're passing to it. Now that's outside of the scope of our certification, but that's the power of star. There's a lot to it that allows us to really work for larger data sets and extract specific files. Instead of having to extract a whole bunch of files, I can just extract specific files. So let's go through a few examples. I'm going to go ahead and remove everything that ends in .gz. I'm going to do an rm-f. I'm going to remove everything that ends in .gz. So I'm going to do *gz. The asterisk here expands on what it means. So it means anything that precedes gz. So that would be hello1 dot, hello2 dot, as long as it ends in gz. So if you notice, my gz's are now gone. So I can also go ahead and do an rm-f, and I'm going to remove anything that ends in tar. That's now gone. So we have our directory 1. Let's go ahead and create two files again, hello1, hello2. Do an ls on our system, and we have a fresh start to look at our archiving utility. So let's go ahead and get started with this. We have star-c. What this does is it creates a new archive, or I'm going to refer to it as a tar file, and write specific names to it. So first, I need to specify the file name of the archive that we're creating. So to do that, I'm going to do a -f equals. So this is different than tar. So -f equals, and then we'll call it my archive.tar, and then the files that we want to add to it. So I want to add directory 1, hello1, and hello2, and we'll hit enter. So it said it created our information for us. I didn't do this verbosely, but if I do an ls, I see that there's my archive. Now I want to be sure that it created it, so I could do a star-t, which this is the same as tar, and then our file name. So we'll do -f my archive.tar. And this lists the contents of our tar archive. Now, I can again optionally send this through gzip. I can gzip my archive.tar. By doing that, you see it's now a compressed archive rather than just an archive. So how can I extract a compressed archive? Well, first, I can do two commands. I can do gunzip or gzip-d and uncompress the individual file. You'll see that we now have my tar. Then I could go and just do a star-x for extract, specify my file. I want that to be my archive.tar. Well, what happened here? What it says is it's not going to override files on our operating system that are newer, so we don't have to worry about overwriting data. So if hello1 was in fact newer, it wouldn't have done anything. If it's the same, it's not going to overwrite it. So it gives us a little bit more protection from overwriting files. When we extract a tar archive, it's not like gzip, where gzip just decompresses a file. Our tar archive is still there. When we extract it, it just pulls that information out of it, leaving our archive intact. Same thing with tar. So by default, the -x flag for star will not extract any file which is older than the corresponding file on disk in our current location. So let's say I just want to go ahead and extract another file. I'm going to accidentally remove hello1. Yes, I want to remove it. Well, I can go ahead and do star-x. We'll do our file equals my archive.tar, and I can specify hello1. And what that did is it just extracted our hello1 file on the system. Since hello1 didn't exist, we didn't receive any type of warnings, and it went ahead and proceeded to perform the action. But what you saw there is I used star to extract just a single file because I was able to specify the file name here with the -x flag. That's how we can use star to remove just individual files. Now let's create a new archive, but let's compress it because issuing two commands sometimes is just a pain. So I'm going to do star, I'm going to create it, then I'm going to compress it, send it through gzip, so it's also the -z flag. I'm going to do the file name equals my compress archive.tar and hit enter. Well, I forgot to enter in what files I want to compress. So I want to compress my directory. I want to compress my hello1 file only. Then we'll hit ls, and you'll notice here it's creating based off the name. But if we do an ls-al, even though we're missing a file, there's compression in here because the sizes vary substantially. So that concludes it for our lesson for learning about tar and star for archiving. We learned how we can send it through bzip. We also learned how we can use gzip to compress and uncompress archives. So that concludes it for this lesson. Go ahead and complete this lesson and move on.